So yesterday we looked at two different dilations here where we were trying to figure out what the scale factor is for each of them. And so we went from red to blue. And so since the blue triangle is bigger than the red triangle, we know that scale factor has to be bigger than 1. So they're multiplying by something bigger than 1, it would end up being a 3. You can tell two ways. You can tell by looking at the side length of the triangle here and seeing that that side length is 2 units right here. And this side length here is 6 units. So they would have times by 3. Or you can do look at the coordinates and see that 0, 2 went to 0, 6. And so that's also being times by 3. Same with example B. We went from red to blue. We went from the coordinate point here. This is 4, 8, because they're counting by 2s. And 4, 8 went to 2, 4. And so they took half of everything. This one shrunk, so it's got to be a scale factor that's between 0 and 1. And we get a half. Then yesterday, I started asking you how the area changes. And we talked about it, but I didn't actually put it in the right spot. So we'll talk about that. It says, how does the dilation change the area of each figure? Well, because side lengths are in 1 dimension, first dimension, but area is in 2nd dimension or 2 dimensions, it's going to have a squared effect on the area. So the blue triangle, if all the sides are times by 3, will be 3 squared, or we said that was equal to what? Jimmy? 9. The area of the blue triangle is going to be 9 times bigger. You can fit 9 of those red triangles in the blue triangle. And it makes sense because you weren't just going to fit 3. More than 3 would fit in there. Okay. And for the triangle or the rectangle here, if the dilation was by half, so all the side lengths are half of what they were, if you square that, what's 1/2 squared? Sander? 1/4. Actually, I need to put 1/2 in parentheses. Shane, could you shut the door for me, please? Thank you. So the area of the blue rectangle is 1/4 the size of the area of the red one. And that means you could fit 4 of those blue rectangles inside the red rectangle. Okay. That's actually what we're going to be talking about today with today's lesson. Okay, which as soon as we finish these last 2 problems, we'll start today's lesson. All right, so the vertices of a trapezoid are, and I've listed them for you, so I'm not going to read them all. Dilate the trapezoid with respect to the origin using a scale factor of 2. So we're going to dilate first, then rotate it 90 degrees counterclockwise. In fact, I'm going to use a different color so we can see the difference there. And it wants to know what the coordinates are of the image. This will be the double prime image. So just to be very clear, what I'm doing right here in the notes is exactly what I'd expect you to do on numbers 23, 24, 25, and 26 on yesterday's homework. Show your arrow notation. Starting with a dilation of 2. If I'm dilating by 2, what should I write on top of the first arrow? Owen? I would be fine with that, but what does k equals 2 actually do? Okay, so it doubles the x coordinate and it doubles the y coordinate. So that's what we would technically write is 2x and 2y. Just shows that you're doubling both of them. And so, Owen, what would the first, what would a prime be? Good, -4, -2. Lucy, what would b prime be? +2. And then c prime would be 0, 2, and d prime would be 0, -2. Okay. Now we're going to do the 90 degrees counterclockwise rotation. Jacoby Gilvin, what happens to the coordinates when you rotate 90 degrees counterclockwise? That's exactly right. Nice job. -y, x. Take the opposite of the y and then flip it to where the x was. So -y, x. Jacoby, what does that make the a double prime unit? Good, 2, -4. And Deegan, what does that make the b double prime?
-2.
Good, yeah, take the opposite of that y right here and then flip it. And then that's going to make -2, 0 for c double prime and positive 2, 0 for D double prime. And that's what you would do on your work paper, except you would need to write all of them out with the arrows and everything else. If you don't want to write the A, B, C, D, A prime, B prime, I'm not going to make you do that, but at least have the coordinates. And please remember that coordinates are inside parentheses. They're not just two numbers with a comma between them. They're inside parentheses to show that it's a point on the plane. Questions on that problem? Can I move on? I'm still writing? No. Okay. The red figure is similar to the blue figure. Describe a sequence of transformations in which the blue figure is the image of the red figure. We had to do a problem like this on our quiz that you got back yesterday. Retake for that is tomorrow. But we didn't have a, dilations. We just had transformations were rotations, reflections, and translations. Obviously, there was some sort of dilation that happened here. So I would start with that first. What do you think they dilated by to go from red to blue? Carson? To go from red to blue. There you go. To go, yeah, 1/2. So you can tell because the red quadrilateral has a side length here of 4, but then over here, that same side length is just 2. So it is half as big. Yeah, so it does make a difference. You have to know we're going from red to blue. It said the blue is the image. That'd be the new one. So we're going to say dilation by half, or you could say dilation K equals 1/2, or however you would like to word it. But the word dilation needs to be there, or at least abbreviated, and you need to have 1/2 as that factor. Don't just tell me it was dilated. Tell me it was dilated by how much. Just like when we put translated. I don't want to know it was just translated, but tell me if it moved right, left, up, down, and by how much. So what I'm going to do is I'm going to, on this graph, determine where this new shape would be after it was dilated, so we can figure out if it was rotated, reflected, or translated, because there was a series of 2 transformations here. So the point 4, -2 right here, if you dilate it by half, is going to become the point 2, -1. So 2, -1 is right there. The point 8, -2 is going to become what point? Xander?
4, -1.
4, -1. This point on bottom, which is 6, -6, if you dilate by half, is going to become what, Dawson? 3, -3. Okay. And then this point here on the left side, which is 4, -4, if you dilate by half, is going to become what, Emerson? 2, -2. So there's my new shape. The reason I want to draw it on the coordinate plane is I want to know what it's going to be after the dilation so I can see what the second transformation was. What was the second transformation? Carson? Nice job. So the second one, to go from the prime image, this is the prime and this is the double prime image, is to go reflection over the x-axis. Nice job. Oops. Reflection over x-axis, or you could say x-axis reflection. All right, got it? Okay.